We're looking at a logarithm that is not a logarithm that is easily found. For example, like if I had a log base 2 of 8, then I would say how many times do I multiply 2 together to get 8, and we would know that that would be 3. But think about, like, for example, this one. How many times do I multiply 70 together to get 17? That's not real obvious. And so we're looking at some type of decimal. So some calculators will actually allow you to type these types of expressions and logarithms in, and some calculators will not. If you have a calculator that does not allow this, then we can use this very simple change of base formula. So what we want to do is change this logarithmic expression to this base of 70, for example, in this one. I want to change that to a base that I can put in the calculator. And there's only 2 types that you can put in the calculator for most calculators. That is common log, which is a base 10, and natural log, which is an understood base E. And it doesn't matter which one you choose when doing this formula, just pick one. Just be consistent. If you choose log, you must use that throughout the problem. If you choose natural log, you must use that throughout the problem. Typically, I just use log because it's easier. Okay, so the way it works is if you have a base of b, an argument of n, but one log here, I want to change that to be log of the argument over log of the base. So notice I've got one logarithm here and two logarithms here. So one more time, log of the number that's given over log of the base, and something simple to help remember is that base goes on bottom. Both of those are b's. So this one is going to be, how do I change this? I'm going to change it to log of 17, so I go straight across over log of 70, and now we're doing base on bottom. So base on bottom. Okay, and then in the calculator, you would just make sure that you put this in with a divide. So I'm going to do log of 17 over log of 70. Okay, and then just round to whatever it says. In this particular problem, we're rounding to 4 decimals, so this would be 0.6669. Okay, let's do the same thing with the next problem. So just converting this, I have log of 22 over log 13. Putting that in the calculator. Log 22 over log 13, and I get 1.2051, again rounding to 4 decimal places. And then here I would have log of -2 over log of 5. So let's put this in the calculator, see what we get. Log -2 over log 5. And oh goodness, we have domain error. Why is that? So I will tell you, one of these numbers is a number that we haven't really been dealing with yet, and that is this negative number. If you've noticed, any previous problems you work with logarithms, there has been all positive numbers. So I want to show you real quick the parent function for a logarithmic graph. So this is the parent function of a log. So this particular graph is log base 2 of x. And I want you to tell me what is the domain of this graph. So if I'm looking at the domain, I'm looking at x values from left to right. It gets really, really close to this y-axis, but never crosses it. So that's going to give me an x value of 0, and if it never crosses, it would just start at 0, and then it goes on and on and on, so it goes to infinity. One thing you do notice with this, though, is that if I went to any negative number on the graph, I would not have a function value for that number. Also, negative numbers are not in the domain of logarithmic functions. So It is completely valid for your calculator to say domain error, and you can say because -2 is not in the domain. And in fact, no negative numbers are in the domain of just a basic logarithmic function. Now, there are some things that we can do to move that logarithmic graph and that function, but that's not what we're dealing with here. Okay? So this logarithm does not exist.